Right, well I think we should get started. Welcome back everyone, nice to see you that you haven't been frightened off. Today I'm going to talk about something absolutely central to philosophy, and that's the methodology of philosophy, which is the methodology of logic and argument. And I think I said something last week about this, but it bears repeating. In science, people do experiments, and the experiments they do are constrained by the laws of nature, which is why there's some confidence that their experiments are going to give them true knowledge. Knowledge. The true knowledge is an oxymoron, but never mind. In philosophy, we also do experiments, but the experiments we do are not constrained by the laws of nature, and we don't do them in laboratories. They're not empirical experiments. Instead, we do thought experiments. So it's very nice being a philosopher because you don't have to leave the comfort of your armchair. You can stay in the library. You don't have to get messed up with test tubes and things like that. You can just sit there and do it in your head. But in the same way as a scientist is constrained by the laws of nature, the philosopher is constrained by the laws of logic. And that's why we can be fairly sure that when we have knowledge, when we think we've got something we know, we can be fairly sure we're right, especially if we corroborate what we think with other philosophers. Of course, third-person corroboration is as important in philosophy as it is in science. But what I'm going to be talking about today is the argument, the sort of logic that constrains our thought experiments. So, first of all, we're going to talk about what logic is. It's not the sort of argument that your teenage children have. Okay, we all know that sort of argument. No, you didn't. Yes, I did. No, you didn't, etc. Nor is it the sort of argument that you laughed at on Monty Python. You remember the argument sketch, probably. Instead, the argument is going to be a set of propositions, which we call premises, which are put forward as reason to believe another proposition, which we call the conclusion. So here's an argument. I want to get to London by noon. I believe it's a necessary condition of getting to London by noon that I catch the 10:20 train. Therefore, give me the conclusion. I must catch the 10:20 train. So what you've got is you've got two propositions. I want to get to London by noon, and I believe it's a necessary condition of getting to London by noon that I catch the 10:20. And together they combine, and you all knew immediately what the conclusion had to be, because there's only one conclusion that's entailed by these two, isn't there? And you all got it right. That's because you are all rational animals. Actually, you do logic pretty well as I do. What I can do that you can't do is tell you how you do logic, what it is that you're doing when you do logic. But as rational animals, you're doing logic all the time. You knew the answer to that, and the reason you knew is because you do logic. Logic is just the, if you like, the method by which you go from one set of thoughts to another thought. It's one way of acquiring knowledge, if you like. Okay, so that's what an argument is. Now, there are different types of logic because there are different types of argument. So, and there are all sorts of different types as well. But one type of argument, for example, is deontic logic, the logic of moral discourse. So, if I say to you, lying is wrong, therefore, what conclusion are you going to give me? Or I shouldn't lie, or something, yeah, something to the effect I should tell the truth or I shouldn't lie, or whatever. Notice that's a different kind of argument because you haven't got two premises there, but you have got a premise again and a conclusion, I shouldn't lie. But it's interesting because Kant says that what's peculiar about deontic logic is you go straight from a statement to the effect that something's wrong to the conclusion that you shouldn't do it. And Kant thinks that that's a very peculiar thing about morality because for everything else you would need a desire in there as well. So if you look again at the first argument, I want to get to London by noon, it's a necessary condition of getting to London, da-da-da-da-da-da, therefore I need to leave on the 10:20. If you took away the desire, would you have a good argument left? No, you just say it's a necessary condition of getting to London by noon that I catch the 10:20. Well, so what? You know, unless you want to get to London by noon, that doesn't entail anything, does it? You can do anything you like consistently with that. But once you've added that, you've got something that requires an action, haven't you? So it would be irrational to have that desire and that belief and not to believe I must catch the 10:20, wouldn't it? Okay?
Unless you had another way of getting it.
That's true, but I have said a necessary condition here. So if I'd taken that out, you're right. But I think as I put that in, anticipating that somebody might say something like that.
I believe it is necessary.
Sorry?
You've only said I believe it is necessary.
That's true, but if it's a matter of action, my belief would be sufficient to, wouldn't it? Because even if I was wrong about that,
You still catch 10:20.
I would still think it's rational. And what's more, I'd still be rational to catch the 10:20, wouldn't I, if I believed that, even if, in fact, I was wrong. Okay? But if you look at this one, do you need a desire in there? Kant would say, no, lying is wrong, therefore I mustn't lie. Do you need, I don't want to do the wrong thing, or I do want to do the right thing? Kant would say no, because he'd say, if you think that you need to add, and I want to do right, you just don't understand what it is to do something wrong. Okay, think about that for a second. If you entertain the possibility that you need to add, I want to do what's right, you're implying that you might not want to do what's right, and Kant would think that that would show that you didn't actually understand what right means. Are you with me?
People don't want to do what's right.
No, and Kant would say they don't understand what's right. If you think, I understand that 10-year-olds go around nicking sweets from shops, because their understanding of right at the moment is if anyone finds out, I'll get into trouble. Okay, wrong is mummy will find out and I'll get a smack or something like that. Ooh, how old-fashioned. Oops, it's illegal nowadays, isn't it? Anyway, whatever. It isn't. Okay, well, at least I haven't said anything illegal, but immoral maybe. So if you're thinking that for something to be wrong is if I get caught, I'll be punished, you haven't yet got the concept of right and wrong, have you? What you've got is a prudential concept that may cause you to act in some of the same ways. But I bet if I leave my purse here when I go out, as I may well do, you wouldn't not pinch it because you might be found out. No, you would have other reasons for not pinching it, mainly because you'd think it was wrong. Probably wouldn't occur to you, but you'd also, if it did occur to you, you'd think it's wrong. So there are different ways, and if you think about it, do you think you could think that lying is wrong, but there's no reason why you shouldn't lie? So of course, let's say somebody says to you, your builder says to you, or your solicitor says to you, well, of course lying's wrong, but that doesn't mean it doesn't mean we shouldn't lie here. Isn't there something wrong with that? Isn't that a contradiction?
But aren't there all sorts of places and
Thank you.
opportunities in which you almost have to lie?
Yeah, that's different. We're saying if you believe that lying is wrong, then you're going to think you shouldn't lie. I mean, if you don't think lying is wrong, then there's no reason not to lie, is there? But if you do think lying is wrong, could you consistently believe, let's say if you believe this lie is wrong, could you consistently believe that there's no reason for you not to lie?
You have to define lying because you have white lies.
I have defined lying in saying you think this lie is wrong, so it's not a white lie.
I'm just saying there are times when you
Yeah.
might lie.
Yeah, but a white lie, we call them white lies because we don't really think they're wrong, do we?
Well, they are, because if you say you haven't dressed...
Right. No, let's not get too away from the topic. If we believe that lying is wrong, or that this particular lie is wrong, even if it's a white lie or not, doesn't matter, could you consistently think, never mind, that doesn't mean I shouldn't do it?
Well, it came up last time with torture. Torture is wrong, but you can get a hard case where you could argue yourself and say it was right,
Right.
because you were saving 1 million others.
Yeah. Okay. I'm going to leave this because maybe deontic logic was a bad idea. Okay. Kant would say that if you believe that, you have got to think, I shouldn't lie. If you think that lying is wrong, you might not, but if you do, then you're going to think you shouldn't lie. Because you cannot think lying is wrong, but that there is no reason for you not to lie. Because for some things to be wrong is itself a reason for you not to do it. It may not be the final reason, it may not be conclusive, but it's a reason not to do it. And that's deontic logic, because you've again got a premise and a conclusion, and the premise gives you reason to believe the conclusion. So that's what's down here. We've got a set of propositions, or one proposition, a premise put forward as reason to believe another. Here's another type of argument. This is modal logic. And I'm sorry, it's a bad example, but I'm lousy at thinking of examples. It's not possible for vixens to be male. That's because vixens are defined to be female. Therefore, that vixen is not male. Okay? If you believe that, you're going to believe that, and that's because if something's not possible, then it can't be actual, can it? Okay? So if it's not possible for me to be male, then it can't be the case that I am male. So you're recognizing that something's not possible will cause you to believe immediately that nor is it actual, because it couldn't be not possible and actual. So that's modal logic, the logic of modality, the logic of necessity. And then another type of logic is the logic of conditionals. So you've probably all heard the saying, if it's gold, I'm a Dutchman. Okay, that means, as we all know, that it's not gold, doesn't it? How do you know that? Well, you'll just have to believe me, take it on authority, that that's because you know the logic of conditionals. And if I were to write the truth table up here for conditionals, a truth table gives you the truth of a conditional in every possible world, you would see that if it's gold, I'm a Dutchman, has to be true. And therefore, it has to be false that it's gold. So I'm not going to go into that. I'm just going to tell you, you know what that means because you know the logic of conditionals, because you're a rational animal. What you don't know is what I know, which is how to draw the truth tables and how to show that that means it's not gold. Okay? Thoroughly baffled, are you? Yes? All the different worlds. Well, some people say that a different possible world is nothing more than a different situation. There's a philosopher called Kripke, very famous philosopher, still alive, or if he isn't, he's only just... It was today or yesterday, and I'm very sorry about it. He believes that you, in order to explain the truth of conditionals, like, okay, if Germany had won the war, we would be speaking German. Now, some of you may think that's true, and some of you may think it's false. We could argue about this. We could give reasons for different sides. But I'll tell you what doesn't make it true, namely that the Germans won the war and we are speaking German, because they didn't. That's a counterfactual conditional. And so we think of conditionals, even counterfactual conditionals, as true and false all the time. And some logicians believe that in order to explain the truth of counterfactual conditionals, you've got to postulate other possible worlds. Now, of course, there are other reasons in physics for postulating possible worlds. In mathematics, there are reasons for postulating possible worlds. What is a possible world? Well, Kripke thinks it is literally another place just like our world, like our universe rather than like our Earth. But there's no causal interaction between one world and another. But you can say, okay, is there a possible world in which Marianne's wearing jeans? Tell me the answer? Yes. Yes. Is there a possible world in which Marianne is male? No. Are you sure? Does anyone think there might be?
Because if you define Marianne as a male.
No. We're asking the question here, could I have been male, or could I... Well, I have been male. In other words, if I had hang on. No, an X and a Y chromosome instead of two X's. Would I still have been Marianne? Would I still exist? Okay, lots of people think no. It's an open question. Some people think no on that, some people think yes. But notice we do think there's a truth value to it. We can ask that question and we can argue about the answer. And it's possible that in order to do that, we've got to postulate the existence of possible worlds, of other worlds that we know about by reason, but not by perception. Do you see what I mean? We can see this world, we can touch it, we can hear it. There, you heard part of it. But you can't see or touch a possible world, but you know they're there because you argue about conditionals. Is there a world in which I'm male? Well, some of you think yes, some of you think no. And the more you look at the logic, the more you might be able to come up with, you're absolutely right, it is no, the answer. Or you're absolutely right, it is yes, or whatever. But that's what philosophers are doing, is sometimes I talk about it as spinning the possible worlds in order to find out what the limits of possibility are. Because if you think of what a scientist is doing, they're looking to see what the limits of actuality are, what is the case in this world, whereas what philosophers are looking for is what could be the case. Okay? Not just in this world, but in any world. Could time travel be possible, for example? I mean, it looks as if time travel isn't possible. Well, we know time travel isn't possible at the moment. Could it be? Is there a world in which it's possible? And if so, could this be a world in which it is? So we're expanding the worlds and asking, okay, we know there are possible worlds. We know there isn't a world in which there are square circles, don't we? Is there a world in which circles are square? Could there be? Could a circle be square?
No, because of the description.
Exactly. It's the concept, isn't it? If something's a circle, it could not be a square. End of story. So we know that there's no possible world in which circles are square. That's not a possible world. Whereas the world in which Marianne is male, maybe that is a possible world. The world in which Marianne's wearing jeans is definitely a possible world. So we're trying to limit the possibilities. Which possible worlds are there and which aren't there? And
Getting back to the Vixen thing, because you're a female, Marianne is a female, and therefore they couldn't exist as male and not.
yes, but what we're asking is Marianne necessarily female? Or is it just a contingent fact that I'm female, in the same way it's a contingent fact that I'm wearing a dress? I mean, I might have put jeans on this morning. Might I have been male? Okay, we know a vixen can't be female because in the same way we know that a bachelor can't be married, because it's part of the definition of being a bachelor that you're part of a definition of being vixen. Is it part of the definition of Marianne, of me, that I'm female? Well, some people do think so, but others think not. You thought not. So there are different views on this one. And I could give you other ones that are where we're not sure. What's important is there are some cases where it's definite, there is such a world, some cases where it's definite that there isn't such a world, and some cases that we don't know about. And the job of a philosopher is to find out about those. Okay? So that's modal logic. And I looked at the logic of conditionals, but there are two main generic forms of argument. Okay, these are looking at particular types of discourse and the logic of that sort of discourse. So as moral agents, you understand something about deontic logic, even if you've never heard about it before. You also understand something of the logic of modality and the logic of conditionals. But here are two very broad sorts of argument: deductive arguments and inductive arguments. Now, I want you to ignore the ones under the dotted lines at the moment and just look at the ones on the top. Now, I know you're all reading the ones underneath the dotted line at the moment. Stop it. Okay, let's look at this one. If it snows, the mail will be late. It is snowing, therefore the mail will be late. The nice thing about deductive arguments is that they give us certainty. They don't give us unconditional certainty, sadly. If the premises of the argument are true, then the conclusion must be true. Okay, so have a look at these premises there and tell me if that's a deductively valid argument. If it snows, the mail will be late. It is snowing, therefore the mail will be late. Could it be that these premises are true and the conclusion false? No. Okay, some people are thinking about it. Let's let them think.
I prefer to replace will with might, and then I consider that it to be a reasonable statement.
But why do we want to do that? Because I'm giving you an example of a deductive argument, and if I change that will to might, then I haven't got a deductive argument, have I? Because then the premises could be false without, could be true without the conclusion being true. And the particular thing about this one is I wanted an example of a deductively valid argument. And what I hope I've got is that if these premises are true, the conclusion must be true. There is absolutely no logical possibility of those premises being true and that conclusion being false. Is that right? Yes. Yeah. Okay, that's great. So we've got certainty in a deductive argument conditionally upon the truth of the premises and the validity of the argument. Now, here's an invalid deductive argument. If it snows, the mail will be late. The mail is late, therefore it's snowing. Okay? Now, there's something wrong with that argument, isn't there? What's wrong with it?
The mail might be late for other reasons.
Good. Give me another reason.
It might still be possible to get there even if it's snowed.
Yes, but can you give me a reason in which... Puncture. Good.
Can't hear.
You can't hear?
Hear the people looking at you in front of
Okay.
you. Can hear you.
Good, I'm glad to say. Okay, well, I'll repeat what was said there. If you've got an invalid argument, what you'll be able to find, or at least what you'll be able to say that there is, you may not be able to find one, because if you're like me, you're lousy at examples. If it snows, the mail will be late. The mail is late, therefore it's snowing. You should be able to find a counter-example. In other words, a situation where the premises are true and the conclusion's false. Okay? So let's say the mailman had a puncture. Okay? If it snows, the mail will be late. The mail is late, therefore it's snowing. Well, no, it's actually the mailman's had a puncture instead, or he got up drunk, or he, whatever happens. There are all sorts of reasons why the mail might be late in addition to it snowing. So we can't go from the affirmation of the antecedent to the affirmation of the conclusion, whereas we can go from this one to that conclusion.
But the first one presupposes some sort of causal relationship between snowing and the mail will be late, which goes in one direction. Otherwise it wouldn't always hold if there wasn't a causation. Whereas the second one, the causation simply isn't going to work. It's not, the causation doesn't, in the first statement, doesn't go in the right direction for that to apply.
Exactly, but the fact is, if you have any argument of that form, you will have a valid argument, whereas if you have any argument of that form, you won't. I'll show you what I mean by that. Hang on, I'll have to find one I haven't written on, and then I won't be able to find where I am, so you'll have to wait while I... if P, then Q, P, therefore Q. Okay, can you see that that's a formalisation of this argument? What does P stand for here? Sorry?
The premise.
Not the premise, no, not the whole... Sorry, if P then Q formalises the whole premise, doesn't it? What does P stand for? You're all too clever, you're all too clever. No, have a look at that premise and tell me what I've taken out and replaced with a sentence letter. Thank you. It is snowing, or it snows. Yep. So P is it snows. So if it snows, then the mail will be late. Exactly. So you see, you've got it now. You didn't know you could all do logic. Therefore, P. So this says
It's snowing.
it is snowing. Notice I should have probably put it, if it is snowing, then the mail will be late, and I didn't. But okay, it is snowing, therefore the mail will be late. Thank you. Okay, then we've got if P, then Q, therefore P. And notice that whereas every argument of that form, it doesn't matter what you put in there, that would be valid. And it doesn't matter what you put in here, it wouldn't be valid, would it? So if we make P, let's change the interpretation. So if I do this, if you were a student doing this, you would have to, and you gave me these arguments, I'd say, where's your interpretation? And if you hadn't provided one, you would lose marks. Okay, so let's give an interpretation. P is, it is snowing. And Q is, the mail will be late. Who's going to try? Actually, all try now. Try and give me another interpretation of those sentence letters. Okay, so forget about snow and the mail. Give another interpretation. Think about Marianne lecturing, or Marianne wearing dresses, or it's being Monday, or... Do you know what you're doing? You're all looking very... oh, okay, you're just looking serious. Good. It's serious stuff. Shh! Don't yell out, you're all trying it. I'll tell you what, when you've got one, put your hand up. And just keep it up till I... Okay, so you're looking for another sentence for P and another sentence for Q, which gives you an argument. Good? Okay, gentleman at the back there, what have you got?
Me.
Yeah.
If Obama wins, the Democrats will be pleased.
Well, you don't need the if, because the interpretation is only for P. So P is...
If Obama wins.
No, not if, just Obama wins.
Oh, yeah, okay, yeah.
Do you see what I mean?
Yeah.
Because if is a logical word here.
It's a logical connector, isn't it?
Yeah, that's right. Okay, and Q is...
The Democrats will be pleased.
Democrats will be pleased. So if we pull that in here, we've got, if Obama wins, then the Democrats will be pleased. Obama, actually we've got a problem here, haven't we? Because notice we've got tense id, which immediately causes us a problem, but let's forget that for a minute. Shall I say Obama wins? Therefore the Democrats will be pleased. Okay, here we've got, if Obama wins, then the Democrats will be pleased. The Democrats are pleased, therefore Obama won. I mean, there must be something else that would please them, wouldn't it? Okay, how about someone else? Let's have just one more. Okay, do you want to have a go?
So when the milkman arrives in the morning, my dog...
Hang on, what's P?
The milkman arriving.
Milkman arrives, okay. And Q is?
My dog barks.
My dog barks. Okay, so if the milkman arrives in the morning, then the dog barks. The milkman arrived, therefore the dog barks. If the milkman arrives, then the dog barks, therefore the milkman has arrived. You can see what's going on, can't you? Any argument of this form means that, because the thing is, P may be a sufficient condition for Q, but it's not a necessary condition for Q, is it? So it's a sufficient condition of the mail being late that that it's snowing, but it's not a necessary condition. And this fallacious argument here suggests it is a necessary condition, and that's why it's never going to work. Okay? Well, you see, you're all doing logic, and what's more, you're all doing formal logic immediately. Fantastic. Okay, so that's deduction, and the nice thing about deduction is it gives you certainty. If the premises are true, the conclusion must be true. But of course, that's quite a big if, isn't it? If the premises are true, the conclusion must be true. Often, we may not know whether the premises are true or not, and therefore we won't know whether the conclusion's true. But the fact that we know the argument is valid is nevertheless useful, isn't it? Because the validity will preserve the truth of the conclusions. So we'll then, if we can show by scientific methods or whatever that the premises are true, we will know that the conclusion is true. And if we can show by empirical means or whatever that the conclusion is false, then what do we know? Good. One of the premises is false. Exactly. So we learn a lot from a valid argument that has a false conclusion. We learn that one of the premises must be false.
Can we say at least one of them?
Yes, you can. At least one of the premises, because it needn't be more than one. Just one false premise is quite sufficient to show that the conclusion might be false. Not is false, but might be false. Okay, good. Fantastic, in fact. Shame about the deontic logic, wasn't it? We might have to go back to that as you're proving yourself to be so good at logic. Okay, let's have a look at induction. Now, induction is different. Inductive arguments don't give us certainty. What they give us is more or less probability. So probability is a matter of degree in a way that validity isn't. Validity is an either-or matter. Either an argument is valid or it isn't. Whereas induction gives us probability, and that's a matter of degree. Okay, you can have strong probability or weak probability. So if we look at this argument here, every day in history the sun has risen. Therefore the sun will rise again. I should have put tomorrow in that, but tomorrow. Okay, that's a pretty strong inductive argument, isn't it? In fact, we're all pretty well relying on it. Anyone who's got a lunch appointment tomorrow, for example, is relying, or a dentist's appointment, or anything else. But of course it's not. It doesn't give us certainty, does it? Because we might be wrong. Tomorrow might be the day when the laws of nature are just going to change. The fact that it's always been like that in the past doesn't mean that it's always going to be like that in the future. The fact that the laws of nature have always been the same in the past doesn't mean they're always going to be the same in the future. It was Hume who pointed out that, as a matter of fact, I mean, it just could be that however strong your deductive argument is, it's not going to give you certainty. Russell talked about the chicken who every day in the whole of his life the farmer had come out and given him food. And the chicken, here comes the farmer, and he thought, oh good, food's coming. And of course he got his neck wrung. Now how do we know that we're not in that position with respect to the sun rising tomorrow? And what Hume said is we don't. There is nothing you can do to show that there's anything more than probability here, because that argument rests on the idea that nature is uniform. Why do you believe that nature is uniform? In other words, that the future will be like the past? Because the future always has been like the past, hasn't it? Well, that's no argument, because that is itself an inductive argument, isn't it? Why has the future been like the past? It always has been like the past. You know, there's not, it's like trying to hop around on one leg here.
Can I ask you a question?
Of course.
That means surely that an inductive argument is based on what has happened in the past.
Yeah.
And a deductive argument is what they imagine will happen in the future.
No. It's certainly true that in induction you're going from something observed or something that has happened to what's the word? Mine's gone blank. No, when you project into the future. Extrapolate. Whoever said extrapolate, that's what I meant. You're extrapolating into the future, aren't you? So, for example, here's another inductive argument. I think you'll agree it's not a terribly strong one. Every time you've seen me, I've been wearing earrings. That's probably true, is it? Especially if you've only seen me last week and this week. Next time you see me, I'll be wearing earrings. Now, that is an inductive argument, isn't it? There's some probability there. But I think you'd agree it's not as strong as that one. Because next time you see me, it might have been as I'm going out to get the paper in the morning before I've even put clothes on, a dressing gown on or something. I don't wear earrings with my dressing gown. And anyway, we know too much about human beings to assume that that's a good inductive argument. So in deduction, you get certainty, and it doesn't need to be about the past or the future. It can be about anything at all. With induction, you are extrapolating from not necessarily the past. You could extrapolate from the present to something else. So all the chairs in this lecture room are blue. Therefore, the chairs in the next lecture room are going to be blue. Now, there's no time element in that, is there? There's just a, you know, and is that a good inductive argument? Well, it's sort of, no, it's not very good, is it? Certainly no, it's not as good as that one. Okay, so these are two types of argument, and whether you've got deontic logic or conditional logic or modal logic or whatever, you'll get arguments of this kind. For example, the argument I was trying to convince you of, lying is wrong, therefore you shouldn't lie, Kant believes that's a deductive argument. Okay, because the premise entails the conclusion. If the premise is true, the conclusion can't be false. Now, some people disagree with Kant, in which case that wouldn't be a deductive argument. Wouldn't obviously be an inductive one either. Incidentally, there are other types of argument. There's, this is where I'm... we've had that one, haven't we? And we've had that one. Okay, there's arguments by analogy. Anyone tell me what one of those is? Give me a very famous one, perhaps to do with watches. Anyone read Dawkins' book, The God Delusion? He talks about a very famous argument from an analogy. Can anyone tell me what it is? The blind watchmaker, exactly so. So the universe is like a watch. A watch has a maker, therefore the universe has a maker. Okay, Dawkins thinks that's an appalling argument, and he's probably right. But it's an argument from analogy. What you do with an argument from analogy is you find something that's like something else, and so if A, you've got A is P, okay, A has this property P, A is like B or B is like A, therefore B has P as well. Okay, so A has this property, B is like A, therefore B has this property too. And of course there, the premise of similarity is absolutely crucial, because if you haven't got the similarity there, then you haven't got the conclusion either. And of course there are arguments from causation. If A causes B, then you don't get an A without a B. Okay? And the reason that that's a valid argument is that you assume that causation brings correlation. If A causes B and you get an A without a B, then that shows you that A doesn't cause B, because an A isn't sufficient for a B. Okay? Right, well let's move on from there. Those are the types of arguments. What's important about any argument, whatever sort of argument it is that if you want to evaluate it, you've got to ask two questions. And the questions you've got to ask are these. Are the premises true? And is the argument valid? And in a case of a deductive argument, what you're asking is it the case that if the premises are true, the conclusion must be true? Okay, that's what you're asking if the argument is deductive. And if it's inductive, you're asking, is it the case that the premises provide good reason to believe the conclusion? So how strong a reason do the premises provide us to believe the conclusion? So those are the two questions you've got to ask. It doesn't matter what the argument is. If you're reading Descartes or you're reading the leader in today's newspaper, what you've got to do is try and firstly analyse the argument. In other words, set it out logic book style. Identify the first thing you go for is the conclusion. Identify what it is this person is arguing for. Okay, that's the conclusion. And then find out what he's using as his reasons. And once you've identified those, you've got the premises. So you should be able to set it out. Premise 1, premise 2, conclusion. And then you ask, okay, what do I think of these premises? Are they good premises? what do I think of this argument? Is it valid? In other words, if the premises were true, would the conclusion have to be true? Or do the premises provide me with at least good reason to believe the conclusion? And if either of the answers to, if the question to, the answer to either of these questions is no, then you don't have a good argument. If the answer to both those questions is yes, you might have a good argument. It's not sufficient. Let me give you an argument that satisfies both of these. I'll get lost again. Okay. Now, is the premise, okay, here's the premise, here's the conclusion. Okay, is the premise of this argument true? Oh, sorry, okay. It says whales are mammals, therefore whales are mammals.
Yes.
Okay, the premise is true? Okay. Is there any possible situation in which the premise is true and the conclusion false?
No.
There isn't, is there? How could there be? The conclusion is the same as the premise. Okay, that is a circular argument. All circular arguments are valid. How could they not be? If the premise is amongst, if the conclusion is amongst the premises, then there can't be any situation in which the premises are true and the conclusion false. So that's a valid argument. But what's wrong with that is it's circular. You're not going to learn anything from that argument. So the fact that you answer yes to both those questions isn't sufficient for it being a good argument, but it's certainly necessary. And that, as a philosopher, those are the two questions that are... Well, actually, as a philosopher, that's the one that bothers you. It's often scientists who are interested in that one. So, for example, every swan I've ever seen has been white, therefore all swans are white. Okay? Well, it may be true that every swan I've ever seen has been white. I need to find out now whether that's sufficient reason for thinking that the swan in the next room is white. I mean, if it's true that all swans are white, the swan in the next room will be white, won't it? But my job is to go into the next room and see if it's white, and if it isn't, what do I know? Well, either that it isn't a swan, okay, or that it's not the case that all swans are white. And maybe we would say it isn't a swan. I mean, you must have heard when Mrs. Thatcher were in, people saying she's the best man in the cabinet. Okay, well, here's the argument. All women are passive. Mrs. Thatcher is a woman. Therefore, Mrs. Thatcher is passive. There's the argument. Well, Mrs. Thatcher clearly isn't passive. Therefore, either she's not a woman or not all women are passive. But, you know, do you see how it works? Humour often depends on logic. Precisely because it tells us what we ought to think and then somehow confounds us. Do you have...
What bothers me, sort of in a sideways way, is the use of the word therefore in that one.
Mm-hmm.
I don't know what I'm really getting at, but it just feels that it can't be a proper argument because the two
are the same.
Yeah.
Well, therefore actually just marks the conclusion of an argument. It says, the thing about an argument is its premises giving reasons for a conclusion. And we can give any premises as reasons for any conclusion. So if I say Melbourne is in Australia, the sea is salt, therefore Paris is the capital of France. Okay? Now, that sounds like a really bad argument, doesn't it? But I could tell you a story about how here we are, not only are we all terribly ignorant, really very badly ignorant, we have been told that these two sentences are such that if they are true, this third sentence is true. Okay? The first sentence is the sea is salt, and the second sentence is Melbourne's in Australia. So I say, okay, you go off and find out whether the sea is salt. Okay, you go off and find out whether Melbourne's in Australia. So off you scurry and you find the nearest encyclopedia or dictionary and so on. You come back and you say the sea is salt, and you come back and say Melbourne's in Australia, and I say, therefore, Paris is the capital of France. Okay, do you see then there is an argument there? And what's made those premises provide us with reason for the conclusion is the context, isn't it? By providing a context, I could make those apparently completely irrelevant sentences an argument. So the therefore just stands for a conclusion to say, I am saying that that is reason to believe that. Now, notice something else. If I add lots of other sentences in here, am I going to change the fact that this argument's valid? Well, let's put in, it's not the case that whales are mammals. It's not the case that whales are mammals. Whales are mammals, therefore whales are mammals. Now, is there any situation where both those premises are true and that conclusion's false? Actually, that's a... They can't both be true, can they? So is this argument valid? Yes, it is, because there's no possible situation in which the premises are true. So how can there be a possible situation in which the premises are true and the conclusion false? I'm going to do a truth table here, which is probably asking for trouble, but let's do it, shall we? Let's okay. This is using the notion of possible worlds to explain something. Okay, I've got if P then Q, P therefore Q. No, I don't want that. Hold on, sorry, I'm changing my mind. Let's try this. Okay, each sentence can be either true or false, can't it? Okay, let's assume for the moment, if you've got a sentence, the cat sat on the mat, or Marianne's wearing a dress, or something like that, it can either be true or it can be false, if it's a contingent sentence. So this truth table represents every possible world with respect to the combination of truth values here. Okay, so this is the world in which P is true and Q is true. Okay, this is the world in which, tell me? Good. Okay, this is the world in which? P is false and Q is true. That's right, and this is the world in which? They're both false, absolutely. You're really doing well here. You've been amazed Harton undergraduates can't do that. It's because they haven't separated the possible worlds, because each of these possible worlds is quite separate from the other. Okay, now in the world where, if we just take P here, in the world where P is true, then the premise here is going to be true, isn't it? Okay, and in the world where P is true here, the premise is going to be true. Okay, and in the world where P is false, and false again, exactly. So, okay, and that's going to be the same here because we've got exactly the same letter here. Okay, now, do we know whether this argument's valid? Well, looking at each structure in turn, is this a world in which the premise is true and the conclusion's false? No. Okay, so that's okay. It's valid there. Is this a world where the premise is true and the conclusion false? Hang on, this is number 2, the second world. Is this a world where the premise is true and the conclusion false? No, it isn't. That's okay. Is this a world where the premise is true and the conclusion false? No. And is this a world where the premise is true and the conclusion false? No. Hang on. Who said yes? Look, is this a world where the premise is true and the conclusion false? No. So there's no possible world. Each of these is a possible world, and these are all the possible worlds, and there isn't one where the premise is true and the conclusion false, is there? This is a circular argument, so we know that this argument is valid. Now I'm going to add not P in here. So I shouldn't have added Q at all. I've just complicated things by adding Q. Ignore it. Let's add not P. Okay, what's the truth value here? P is true, so in this world, not P is false. Good. Sorry, that's a not. That is not. Okay, in this world, P is true, so not P is false again. In this world, P is false, so not P is true. You're really doing well. Okay, and in this world, P is false, so not P is true. Okay, so now we're looking at two premises, and let's see if we can find a world in which the premises are true and the conclusion false. Okay, so this world, the world number one, we've got two premises. Is this a world where the premises are both true and the conclusion false? No, because the premise is not both true. This one's false, isn't it? So, okay, this is valid. That's all right. Here's one where, okay, is this a world where the premises are both true and the conclusion false? No, it isn't, is it? Okay, is this a world where the premises are both true and the conclusion false? No, and is this a world in which the premises are both true and the conclusion false? So is the argument valid? Yes. Good. Really good. The thing is, you can add any premise to a circular argument and it remains valid. So it may be that a circular argument, when I look at that therefore, you think this isn't an argument, it's so obviously not valid. Now, if I were a politician wanting to kick sand in your face, the best way to do it would be to offer you a circular argument, but in the middle, blind you with science, hide the premise that is the conclusion in amongst lots of other premises, so you wouldn't see, you know, the therefore would sound fine to you then, because it looks as if you'd have an argument, but actually it wouldn't change the validity, would it? You, as a rational animal, would recognise the validity. What you wouldn't recognise is that the argument is valid because it's circular. Are you with me? So circular arguments are jolly useful if you're trying to confuse someone. And the reason they're useful is because you, as rational animals, are validity detectors. That's what you do. You know, if we're in the pub and I'm giving you an argument, you're sitting there thinking, is that a good argument? Is she right? Is she right? You're asking yourself whether my argument is valid. You're setting yourself to validity detection mode.
Would you relate that then? You know that kind of old, I don't know what you call it, quiz kind of thing of somebody, there's two doors and one's a liar and one's a truth person. Yeah. And you've got to ask them one question and work out which is the right. Is that the same? Would you use? Yeah, you could use it. The thing about that is it's self-referential, because the liar, if I say I'm telling the truth and you don't know whether I'm a liar or not, you don't know whether that sentence is true. But yes, you could use truth tables for that. Yeah. The outcome is still true.
Yeah.
And then one doesn't work with the other premise, if you know what I mean. Like two different answers could still give you. I was just a bit confused by the first bit before when it was like one. Then I'm sorry, but you could use that. That's the.
You could use that. Were you being confused by the fact I put Q in there? Do you think, or were you being confused by the fact I wrote that out first?
No, just the initial statement that said whales are not mammals and whales are mammals.
Whales are not mammals, therefore whales are not mammals. Yeah.
Yeah, that was it said whales are not mammals, whales are mammals, therefore whales are mammals.
Okay.
But that's still true, but then that's kind of not.
Yeah, if you look at it, that truth table I've just done is exactly that argument. If we provide the interpretation that says P is whales are mammals. Do you see? Because when you look at that, P is whales are mammals, not P. Sorry, this is. Yeah, P is whales are mammals. This says it's not the case that whales are mammals, and this says whales are mammals. So that's the truth table for that argument. Yeah. And I drew that, and I then didn't do it because I realised it wasn't circular. But if I do the truth table for that one, what's going to happen? Does anyone recognise this argument? If P then Q, P therefore Q. Is that going to come out valid? It's not circular, because the Q isn't a premise. The Q is part of a premise, and that's different. That's okay. So that's not circular. If you had Q in here, it would be a circular argument, and it would be valid for that reason. What's this argument? You've seen it today already, or rather, this is a formalisation of an argument you've seen today. Snow. Thank you. Exactly so. If it's snowing, the mail will be late. It is snowing, therefore the mail will be late. And if I write out the truth table, and you'll just have to take these for oops, yes, that's right. Okay, there's the therefore. Is this a world in which the premises are all true and the conclusion false? No? Okay, so that's all right. Is this a world where the premises are all true and the conclusion false? No. Is this one where the premises are all true and the conclusion false? No. Is this one? No? Okay, so that argument's valid. But if I change this to a Q, sorry, I'll get another pen because it's okay. Is this a world where the premises are all true and the conclusion false? Okay. Is this a world where the premises are all true and the conclusion false? No. Is this a world where the premises are all true and the conclusion false? It is, isn't it? Okay. That is quite sufficient to show that this argument, any argument of that form, is invalid. Because here's a world, here's a possible world in which the premises are true and the conclusion false. And all the rest becomes irrelevant because you only need one counterexample. And we can even say what the counterexample is. Because that argument is invalid in the world where P is false and Q is true. So if we put in the interpretation we had before, what was P? It's snowing. And Q is? The mail is late. So in the world where P is false, in other words, it's not snowing, but the mail is late because of that puncture, that's the counterexample to this argument. Do you see? Do you see how useful logic is? It's fantastic. And you see, you're doing it now. Okay, you've got a fair amount of help here, but it wouldn't take me long to show you how to do this yourself. The really difficult bit is the interpretation from English into formal logic. That's the really difficult bit. But this bit, dead simple once you know how to do it. And this is formal logic. Okay, right, actually that takes me quite neatly on to the next slide, because I wanted to point out that there are two sorts of logic. So far we've been looking at formal logic, but I also want to say something about philosophical logic, because that's a bit different. But firstly, just to say something a bit more about formal logic. You've got to distinguish form from content, the form of the argument from the content of the argument. So this is the form of the argument up here. The content is supplied by the interpretation. So you notice that you could give this a completely different interpretation, but the form would still be the same. And that's actually very important, because what that tells us is that logic is topic neutral. Once you know how to do logic, it doesn't matter what subject you're talking about. The logic will work for any subject at all. So let's look at this one. Let's look at, here are two arguments. Sorry, I'll move this over. All men are mortal. Socrates is a man, therefore Socrates is mortal. All actions that produce the greatest happiness of the greatest number are right. That action produced the greatest happiness of the greatest number, therefore that action was right. Now, can you see that these two arguments, completely different subject matter, aren't they? This is about mortality and Socrates, and that's about ethics, the greatest happiness of the greatest number, etc. But they've got the same form, and now I want you to practice your logic by telling me what the form of this argument is. Okay, work it out for yourself, and then put your hand up when you've got it without yelling it out. Work out what the form of that argument is. Remember that there are logical words and there are English words, and it's the logical words you want to leave in, and the English word, well, they're all English words, but leave the logical words in, provide an interpretation for the non-logical words. Don't worry if you're finding this difficult. This is difficult stuff. Put up your hand if you think you've got it. Let me give you a tip that all is a word that you leave in, and is a word that you'll leave in. Put up your hand if you think you've got an answer. Good, we're getting there.
Is formal logic the same as symbolic logic?
Yep. Symbolic logic. Because the form is captured in symbols. Good, okay, we've got a few. Do you want to have a go?
All A is B.
Okay. Hold on. Surely somebody could invent something better than this, don't you think? What?
It's called a crayon.
A crayon, yes. Yes, would work, wouldn't it? All
A is B.
All A is B. All A's are B. Can I change it? Yeah. Okay. All A's are B.
S is A.
S is A.
So
Therefore,
is B.
give the girl a gold star. Fantastic. Do you see it? All A's are B. S is an A. Therefore, S is a B. And what about up there? Let's provide the interpretation for each of these arguments. Okay, so the interpretation says, what does A mean? What does B mean? And what does S mean? And we've got two arguments, so we need to provide two interpretations. What is A here? You're doing this out. If we do the first argument first. X is a man is what it is actually. I'll put that in because these are predicates. Is a man is a predicate, so you need to have a placeholder. X is a man. B is... X is mortal, yeah. And S... Socrates. Well done. Okay, and the interpretation here, A is... X is... It's a bit long-winded, this one. A is an action that produces the greatest happiness of the greatest number. And B is right. X is right. Well done. And S is well done. Well done. That action. Because that action is a designator, isn't it? That action, it picks out one particular thing, in this case an action, in the same way that Socrates is a designator, it picks out one particular thing, Socrates. So we're saying, the first one, anything that's a man is mortal, so anything that has this property also has that property. Socrates has this property, the first one, therefore Socrates has the other one. Okay, and we're saying exactly the same thing in that one, except we're talking about something completely different. We're talking about actions and whether they produce the greatest happiness, the greatest number or not. So do you see why logic is topic neutral? Once you've learned logic, it doesn't matter what you're thinking about, you can think clearly about it. And this is one of the joys of being a philosopher as far as I'm concerned, because it means you can put your nose in anywhere. It really doesn't matter what you're talking about. There's a philosophy of mind, a philosophy of biology, a philosophy of chairs, probably. Somebody was trying to persuade me to run a weekend school on the philosophy of accountancy yesterday. If anyone would like to do that, they can share it. No, actually, I'm sure that there is a philosophy of accountancy, and actually, if there are, I'm sure, philosophical issues in there. There is a philosophy of everything because of this. Okay, logic is the methodology of philosophy, and it can be applied to any subject at all. And that's because logic is topic neutral. Okay, let's move down. So what we do in formal logic, as you've seen, is we strip an argument of its content. We're not interested in the content. We reveal its form, and then we can test mechanically for validity. And you've seen me test mechanically for validity here. That's one way of testing mechanically for validity. Okay, now the trouble with that is, what happens if I add another premise here? So I have an R as well. It's going to get unwieldy, isn't it? And just for fun, I always get undergraduates to do one with 4 or 5 premises in, so that their truth table goes on and on and on, and it's very, very boring to work it out. And then I show them that they can do this instead. If I can find a... Okay, now you'll just have to believe me that that arrow means if then. Okay, so that formula there means if P then Q. And that little sign there means it is not the case. So that means not Q. And what I've done here, you remember the argument we had, if P then Q, P therefore Q. I've got the premise there, the first premise there, the second premise there, and I've negated the conclusion. Okay, because the argument was if P then Q, P therefore Q. And I'm saying, well, let's pretend that we've got if P then Q, P and not Q. In other words, a situation in which the premises are both true and the conclusion's false. Let's see if I can find an argument like that, or a situation like that. And I then apply completely mechanical rules that I could again teach you in an hour or so to get this. Okay, that the conditions under which that are true. that is true. Are there two situations? It's true just in case not P or Q, and you can't, there is no possible world with both Q and not Q in it, so that's not a possible world. There's no possible world with not P and P in it, so that's not a possible world. There is no possible world in which the set consisting of the premises and the negation of the conclusion are true together. Okay? Now, you won't have understood that, but I hope you can see that I know what I'm talking about, and that it would be very easy to teach you how to do this. So that all you have to do is any argument at all, if you can translate it into symbols, and that's the biggest if you can translate it into symbols, there is a set of rules such that you can apply these rules and test it just as I have done and say quite categorically, this is a situation in which, this is an argument that's valid. And let's do the invalid one just to see again how it works. The invalid one is if P then Q, Q therefore P, so I'm negating P because that's the conclusion. And I want to see if there's a possible world in which these are all true together, the set consisting of the premises plus the negation of the conclusion. Well, that's true just in case not P or Q again, but we don't have any contradictions here, do we? See, we've got not P, Q. There's one possible world in which that set are all true. The sentences in that set are all true. And we've got Q, not P, Q. So that's another world in which the set consisting of the premises plus the negation of the conclusion are all true. So either of these, any situation in which Q and not P is true is a counterexample to that argument. And you go to your interpretation now, you find out what Q is, you find out what not P is, and you know what your counterexample is. Magic, isn't it? Well, yeah. P, it is snowing. Q, the mail is late. Do you see what I mean? I was just doing exactly the same example. Don't worry if you're getting confused here. That you don't know these rules. You have no idea why I've represented the truth conditions of that like that. And I would have to tell you that. And I'd also, given that that's actually quite difficult to understand, I'd have to convince you that that is the case. But I would be able to do it, I promise you. And once I'd done it, you would then be able to take any argument and show whether or not it's valid or invalid. And if you showed it was invalid, you'd also be able to give me the counterexample, because you would know which world is such that the premises are both true and the conclusion false. Isn't it nice?
Can I just ask, are you doing it because, well, would you be doing it because you'd be trying to show that in fact it wasn't the case that P, therefore Q? Is that why you'd be using that kind of...
Are you understanding that as the therefore? You said P, therefore Q.
P, therefore
Yeah,
Q.
that's not a therefore. It's an implication, not an entailment. That's saying if P, then Q, not P, therefore Q. I mean, don't worry too much about that.
Sorry, I think
The therefore would be...
I said that wrong. I think I am assuming what you said it meant originally, if P,
Okay.
therefore Q. So what I was asking is just, would you be using... I'm just trying to get an idea of
Yep.
why you might use that kind of diagram. Is it because you would be trying to challenge somebody's argument and say, well, in fact,
Yeah.
it's not the case if P, therefore Q?
Well, what I'd be saying is, if anyone made this argument, this is the argument they'd make. They'd be saying, if P, then Q, and P, then Q. So if these are true, then Q is true. So if it's true that if it's snowing, the mail will be late, and it's true that it's snowing, then it must be the case that the mail is late. And I would do this sort of diagram, and I'd say, you know, you're right. That's absolutely right. But then if somebody tried the other argument... so as I'm reading Descartes, for example, and I think, okay, what he's saying is that it's possible that all our beliefs about the external world are false. Okay, and one of his premises is this, one of his premises is that, one of his premises is this. is it true that that conclusion really follows from those premises? So I would do the truth table and I would say, no, it isn't true, or yes, it is true. And that would enable, or you could look at the leader in tonight's paper and say, okay, here's the argument, premise 1, premise 2, premise 3. I'll now formalise the argument, I'll strip the content out of it and formalise it, and then I'll apply the rules of the predicate calculus would probably be needed. This is the propositional calculus, but you'd need a slightly more sophisticated one, predicate calculus, and you'd be able to determine whether the argument is a good one or not. Of course, what you're determining is that the argument is a good one or not. That still doesn't tell you whether the conclusion is true, does it? Why not?
We don't know whether the premises.
Exactly. The fact that an argument is valid isn't telling you that the premises are true. So, as a philosopher, what you're interested in is the validity of the argument. You're also interested in the truth of the premises if it's a philosophical argument, but it might be an empirical argument, in which case the truth of premises isn't your business. You know, we don't go around getting our hands dirty.
If this stuff has existed for centuries, why don't all philosophers submit their own ideas to it?
They do.
And then, so everything you can analyse all the philosophers' statements and say, it's all true, it's all true, it's all true.
No, it doesn't work like that, because firstly, you've got to be able to formalise an argument, and there are huge problems. If this is the class of all arguments in the world, okay, all arguments here, you can formalise, I'm making this up, but let's say you can formalise that many in the predicate calculus, you can formalise that many in deontic logic, you can formalise that many in modal logic. This lot you can't formalise at all, and therefore you can't apply the rules. Now, what we hope as formal logicians is that we will learn how to formalise those. And for example, the predicate calculus was developed only a couple of hundred years ago. Aristotle developed syllogistic logic, but it took Frege to develop predicate logic, and that was a huge leap forward. Modal logic has only been developed, well, it's still being developed. The logic of probability, ditto. Deontic logic, we're still working on it. So, you know, you're right at the cutting edge here. I've given you the noddy calculus. If you want to go and do it for yourself, you'll have to do a lot more than I've given you here. But you'd know that. I mean, so no, it's not the case. And of course, also the real skill is in translating the argument. And you'd know that if I made you do some, because it's really, really difficult to translate from English into a symbolic language. And there are a lot of things left out, and it's very frustratingly inaccurate, and so there are real problems. But we all do it all the time. Believe me, I sit in my study doing tables like that. It's much more interesting than you might think.
There must be cases, I mean there are cases presumably, where you need more than one premise before Q follows.
Yeah.
So it would be like P plus P plus P, then Q.
Well, I mean, there's more than one premise in the arguments I've been doing, of course. That's one premise, that's another premise. And of course there could be, I mean, there could be 10 premises here. I could still apply these rules.
I mean, how can you, is there a way of working out how many of the premises need to be true? In other words, they may not all need to be true.
No, you only need one that's false. And that's quite sufficient to show that even if the argument's valid, the conclusion may be false. Yeah. So the number of premises that's true is not very relevant. It's if there's at least one that's false. Here's a valid argument with a false conclusion. I think I wrote it down. Hang on, I've written it here. If it's Tuesday, then Marianne isn't lecturing. It is Tuesday, therefore Marianne isn't lecturing. Okay, well that's a valid argument, isn't it? Do you want to hear it again? If it's Tuesday, then Marianne isn't lecturing. It is Tuesday, therefore Marianne isn't lecturing. Now, if those premises were true, the conclusion would be true, wouldn't it? Okay? But the premises aren't true, are they? Neither is the conclusion. So you can have a valid argument with a false conclusion. If you then know that the conclusion is false, of course you can go back and say one of the premises must be false. But there are often situations where we actually don't know whether the conclusion is true or false, and therefore we don't know whether the premises are true or false. You know, I mean, logic is in some ways the servant of science. In other ways, of course, science is the servant of logic. I mean, they work together.
But does it tell you anything?
Oh, yes. It tells you a lot. It tells you whether an argument is valid. And you know that okay, think of the difference between something's generating truth and something's preserving truth. Logic doesn't generate truth. If you haven't got truth in the premises, you won't have it in the conclusion. But if you have got truth in the premises, you preserve it in the conclusion by using a valid argument. And that's what you hope. Because there are things that we know about the world, and there are things that we want to know about the world. So we want to extend our knowledge from what we already have to what we don't already have. And one of the ways of doing that is by using logic. If this is true and this is true, then this must be true.
But it's the if.
The if is...
If this is true,
Yeah.
then this is true. Or if
Yeah.
this is true, then this happens, or whatever. But we don't know whether it's true, because you've got an if in there that shows that you don't know whether it's true either.
Well, let's say I'm a scientist and I say, well, if the Higgs boson exists, then my building this whacking great hadron collider at the cost of millions and millions and millions of pounds might enable me to find it. Of course, if the Higgs boson doesn't exist, I've wasted all that money. Well, you know, it may show me a few other things, but it won't tell me about the Higgs boson. So if statements are actually, we use them all the time. I mean, if you think of any of your practical reasoning that says, okay, I want to do liver for supper tonight, therefore I need some onions, or something like that. Therefore, I haven't got any onions. You're using if statements to generate conclusions about actions or conclusions about knowledge, or you can't reason without if statements. This is, yeah. I mean, it was when this was developed that computing became possible. Yeah.
The logic you are talking about is no different to the logic that you find in the computers. It's just the same.
Yeah, absolutely the same. Exactly so. Yeah. Yeah. No, I mean, what you're doing when you're doing the applying those truth tables and the tableau rules is acting like a computer. You're making like a computer.
Or if you're saying something like, if the world is getting warmer, this implies. But if there is a blip in a tendency towards new ice age, then all the proceedings...
Exactly. I mean, you might have two conflicting theories, and you're saying if this is true, then this will be the result. Let's see if this is the result. But if this is true, this will be the result. And if we can find out whether it's this or that, then I know which theory is the correct one. Do you see? All reasoning you cannot do without if statements. And I can tell you under exactly what conditions if statements would be true. I might need to go into the laboratory to see if an if statement is true. Actually, I wouldn't, because there's no way a laboratory can tell me.
That's a wonderful example you've got, because I believe there's global warming because of our activities, but some people don't. So, and they're saying, no, this is a natural thing. This happens every so often in the course of world history, past history.
So, do you see that now we have scope for going into the laboratory or the Arctic or wherever we go to find out, but without that bit of reasoning first, you wouldn't even know what you were looking for. And the thing is, if logic can rule out something, then there's no point in going to the laboratory at all. I mean, if I can show an argument is invalid, then any scientist who's trying to get funding on the back of that argument is in serious trouble. Because, why should I fund him? Okay, moving on, because we've only got 5 minutes left, but that's all right, because, okay, I was going to talk very briefly about philosophical logic. I've talked about formal logic, but philosophical logic is the philosophy of logic. I said there are philosophies of everything, including biology, accountancy, whatever. But the philosophy of logic is, as you can imagine, pretty damn important to philosophers. Because the philosophy of logic looks at the notions without which logic can't work. So we've talked about truth a lot today, haven't we? I've drawn truth tables, I've drawn truth trees, I've said if this is true, that's true. So the notion of truth is absolutely central. Well, what is truth? Go on, tell me. You've all sat there looking intelligent as we've talked about truth, so I assume you understand the word. Tell me, what is truth?
Something that's correct.
Something that's correct. What's correct then? I mean, you're just giving me a synonym there, aren't you? Whoever it was. Okay, so...
Opposite of false.
What?
In this case, opposite of false.
Okay, what's false then?
There's no one without the other. So.
No, okay, but that doesn't tell me what either are. It's true, you can't have truth without falsehood. You can't have falsehood without truth. But what is truth? A fact. Okay, what's a fact? Hang on. Let's. What is a fact? Certain knowledge. Is knowledge a fact? I mean, there's the knowledge that I'm wearing a dress, and there's the fact I'm wearing a dress. Are they the same thing? No, because there are facts of which we know nothing, aren't there? So facts are nothing to do with knowledge, but.
Does truth have to conform with reality and then define reality?
Well, reality sounds like a synonym for truth here. A fact is actually something that makes a true sentence true, isn't it? Think about it. What is a fact?
Something you can prove.
No, there are facts you can't prove. I mean, are there 3 consecutive 7s in the decimal expansion of pi? If there aren't, then you can't prove it. I'm told there are, by the way, so that's out of date, but just imagine, the decimal expansion of pi is an infinite expansion. If there aren't 3 consecutive 7s, there's no way we're to be able to prove it. But it would still be a fact, wouldn't it? So knowledge of a fact and a fact are 2 quite different things. And what is a fact? A fact is something that makes a true sentence true. So talking about facts doesn't tell me anything about truth. So come on, you've all been dealing with truth. What is it?
It has to be something which corresponds to something we know, but then how do we know it? It may not be sense experience. It may
No, we don't need to know it at all. No, you're all confusing, not all of you maybe, epistemology and metaphysics here. Epistemology is what we know, and metaphysics is what is the case. And they're 2 quite separate things. What were you going to...
Belief.
No, because a belief is usually to do with knowledge rather than... Because there might be facts about which we have no beliefs. I mean, you have no beliefs about my middle name, I shouldn't think. You don't even have the belief that I have one. How do you know whether I have one or not? Okay. But there's still a fact about my middle name. Irrefutable is to do with proof again, isn't it?
Yeah, so I'm saying the premises
Yeah.
before they always...
Yeah. No, that's again to do with epistemology. No, the fact is, truth is a very, very difficult... You mentioned correspondence. There are 2 key theories about truth. Actually, here's another one. There's some belief that truth is nothing, that truth is completely redundant. Because if I say P is true, I'm not saying anything more than P, am I? If I say P is true, am I saying anything more than P?
Well, you're saying not P.
No, I'm not. I'm saying not P. Aren't I? Because if P is true, then not P is false. So if I'm saying P, I'm saying not P, not P. You too can do this. Eventually. Is truth demonstrable? Not always, no. No, definitely not.
Covers moral, what we regard as moral judgments. opposed to factual.
Well, I think there are facts about values, so I don't think there's any opposition between fact and value. So I think there are moral truths, and that what make a moral truth is that there are moral facts. No, you can think of proof again. Think proof is to do with knowledge. Anyway, some people think that there's no more to truth than coherence. What makes one belief true is that it coheres with your other beliefs. Other people think, well, hang on, I can have a set of beliefs here, all of which are coherent, and then if I negate them all, that'll be another set, all of which are coherent, won't it? But which is true? So coherence can't be the right theory. Well, no, because truth seems to be a property of sentences and beliefs, doesn't it?
Yes, and reality doesn't.
Well, reality isn't a property of your beliefs, is it? Or of your sentences. Exactly. But truth seems to be a property. If there weren't any beliefs in this world, there wouldn't be any sentences, would there? Sentences express beliefs. Okay, if I believe that what's your name?
Deirdre.
Deirdre is wearing red, I've just expressed that belief in saying Deirdre is wearing red. If there were no beliefs, there'd be no sentences. If there were neither beliefs nor sentences, there would be no truth, but there'd still be reality.
Isn't that just semantics?
Semantics means truth, or it means truth conditions.
Well, does it necessarily?
Yeah.
Does it?
Yeah.
I thought that truth is something that exists despite, no matter whether we know it is truth or not.
That's because you're thinking of what makes things true. But of course, truth is still the property of the sentence that you've uttered. I mean, what's true is the sentence. The reality is what makes it true. This is really difficult stuff here. Just talking about semantics and syntax at the moment, if we look at one of the truth trees again, I have stripped the semantics out of the arguments there. I've left the syntax. All I've left is the shape. If I want to put the meaning back in, I've got to put semantics back in. And in putting semantics back in, what I'm putting in is conditions of truth and falsehood. That's what semantics is. And that's what meaning is. Anyway, we've done it now. That's logic. That's your lot on logic.
We've got truth is either redundant or coherence with other beliefs.
Oh, okay.
Another one.
Correspondence. Correspondence, so we've already looked at that. Truth is correspondence between a sentence and a fact. But what's wrong with that is what is a fact other than something that makes a true sentence true, and therefore that's just a circular definition. It gets you absolutely nowhere. Oh, goodness, it's lots of people. Yeah, AJ would certainly be one of them, I think. So what is truth? Answer, I don't know. I know more than you do, obviously, but I don't know, because this is still an ongoing question. What is truth? That's what philosophical logic looks at. We also, validity, I gave you one of the paradoxes of entailment a minute ago, and you weren't very happy with it. Here's another two. Well, it would be if I could find them. We're running over our time. If anyone wants to go, they're most welcome. No, I'm not going to be able to find it. If I say the grass is green, therefore 2 + 2 = 4, that's a valid argument, because there's no possible situation in which that conclusion is false. So how could there be a possible situation in which the premise is true and the conclusion false? There couldn't be. That's one of the paradoxes of entailment. And one of the things that philosophical logicians would like to know is, why is our definition of entailment faulty in that way? Because surely that argument isn't valid. And yet our definition of valid makes it valid. So there's something wrong with our definition of validity. And yet somehow we can run computers that run Large Hadron Colliders and find the Higgs boson on our logic. So our logic isn't totally wrong. How do we deal with it? Okay, we're going to stop right there. You know nothing about identity, but that's all right. I'm sure we can talk about that some other time.